What?
I said you're working on your geometry final?
Yes, I am.
Okay. So how are we going to do the problems? Have you sent me an email or geometry
I will.
tends to
I
be
will
a
do.
little tough to verbalize.
Yeah, I'll send you my study guide right now.
Okay. And you know you have my email address. It's David Cowan 1949.
Yep.
Okay. Just send one picture at a time. If you put 6 pictures in there, it'll take a half an hour for me to get it.
Oh shoot. Oh, that's what I just did.
If you put one picture in there, I'll get it in 15 seconds. It makes that big a difference. It's really kind of amazing.
Hmm.
Try it again. You may have to stop the first transmission. I don't know. I ran into this yesterday with a student. He did
Okay.
the same thing. And yeah, the first one just takes forever to go out. Um, so if you can try it again with that first page, try that and just attach one file. Are you using
Okay.
an iPhone?
I'm using an Android.
An Android, okay? Should be no problem. I was going to say if you're using an iPhone, make sure you attach it as a large image file. But if you're using the Android, I don't think it even gives you that choice. You just attach it and send it as a photo.
Yeah.
Tell me when the one that has one picture attached says file sent. And then I can start looking for it.
All right.
There it is. Geometry Final Study Guide.
Yes.
Okay, perfect. I can just scroll down this thing. Wonderful. Well, I wish everybody sent me stuff like this that I could just scroll down like that.
Yeah.
Usually I have like 6 separate pages.
Yeah.
Okay, so this is only a partial review. Not much blank space, so you need your own paper.
Yeah. That's what I have right now.
Okay, good. What I'm going to do is write right on top of this document.
All right.
So if ST bisects MN, what can you say? In other words, all these geometry problems, first step is to get it into an equation that you can solve. Always.
Yes.
The
So
relationship
what?
between MA and AN.
What I did was 3x plus 8 plus 20 equals 180.
Okay. Here's the thing. When it says it bisects the line MN, it's not talking about angles. It's talking about the length of those line segments.
Ah.
So 3x plus 8 is equal to 20.
Ah.
In other words, AN is from there to there. That's 20. MA is from there to there. That's 3x plus 8. And this line, when it says it bisects it, it means it takes that MN and splits it into 2 equal parts.
Ah.
So how do you solve that? 3x plus 8 equals 20. Next line.
So we're still on one, right?
Yeah, you
Okay.
just solve that equation there.
Okay. So I subtract 8 and subtract the 20.
Hold on. Just, I tell you what, read the next line. In other words, if you're doing this on paper, what's your next line going to say? Algebra, you generally just do one line at a time, which handles one step at a time.
Okay.
So you're going to subtract 8 from both sides. What's the next?
Yeah. So 20.
No, you're subtracting 8 from both sides. This is what you're doing. So what's the left side become? Always go left to right.
So it just be 3x.
What's the right side become?
12.
Now what's x equal to? You solve 3x equals 12. You divide both sides by 3, right?
Yes.
So you
And
get
that would
x equal 4.
yes.
Okay. And that's what they wanted, was what is x equal to? It's equal to 4.
Oh, okay.
Let's look at number 2. You want to just go in order of these?
Yeah, that would be cool.
Okay. Now, in this case, line BC bisects that angle B, or ABD, however you want to call it.
Mm-hmm.
And you know that because that, with a single hash mark through, is the same as that. So what's this lower angle equal to?
27 degrees.
So what's angle CBD?
27 degrees.
Yep.
Cool.
Number 3. They want to know MNQ. So they want to know this one right here. Okay. And they've told us this angle, and they've told us this angle.
Mm-hmm.
So what's the one they're looking for?
M and Q.
That's this one right here.
Yeah.
So if you know the big one and you know this one, how do you get this one?
Don't you subtract?
Yep. What do you get?
Mm.
In other words, this angle that they're looking for plus this 38-degree angle equals 112. So if you call this angle x, you can say x plus 38 equals 112. So what's x equal to?
74.
Okay. Let me scroll down a little bit here so I got a little bit of room to write.
All right.
Complements of 67 degrees.
Oh, I actually understand that.
Good. You can direct me if you like. If you don't need to go over every one of these, and certainly if you know how to do it, you don't need to go over it.
Yeah.
So you pick the numbers and we'll go straight there.
Okay. So just tell me if I'm right or wrong. So for the complementary, or whatever you want to call it, isn't it like you subtract 180 from the degree?
That's supplement. Complement is 90.
Yeah.
So what's the complement of 67?
23.
And what's the supplement of 67? Supplement means 180.
Yeah. My bad. 113.
What's the complement of the supplement? Well, let's figure out the supplement first.
Okay. 51.
Okay, so I'm going to cross out supplement of 91 and put it 51 in there. Now, what's the complement of 51?
39.
Okay. Number 7. Find the value of the variable and the unknown angle measurements. Okay, first of all, what's x and y? You know what? Let me blow this up just a little bit more, and I'll have a little bit. Writing in these small spaces is a little tough, a little tricky.
All right.
So, okay. Can you see that okay? So what's
Yes.
x?
Okay.
When I have two lines crossed like that, angle 1 is equal to angle 2. They're called vertical angles. Angle 3 is equal to angle 4. They're called vertical angles. So what is x?
83.
Yeah. So that's 83. And again, we see that angle with a hash mark, and that's what y is also. So what is y?
83.
Okay. So x is 83, y is 83.
Mm-hmm.
Now we need z. I want to think about this for a moment.
Okay.
What's this angle right here?
Which one?
It's the same as that angle, right? My two check marks, those are the same. You got the angle sign with the double hash mark on both of them. It means they're equal. Is this a straight line?
No.
Yeah, it is.
Oh, yes, sorry.
Okay. Well, if that's a straight line, those two angles are also a linear pair. In other words, if 1 and 2 are a linear pair, meaning they are supplementary always. So if they're equal and supplementary, what must they be?
That equals to 180.
Yep, they equal to 180 and they're the same angle. So what do they have to be?
183.
No.
Right.
Here's the straight line. There's another straight line. They're saying this angle is equal to this angle.
Yeah.
Well, if the whole thing is 180, what do each of these angles have to be?
90 degrees?
90. Not 93, 90. In other words, that has to be 90 and this has to be 90. Otherwise, this would not be a straight line. In other words, that adds to 180. Vertical angles always have to add to 180. 1 plus 2 is 180. Okay? Or a linear pair is what I meant. All right, so I screwed up here and erased everything. That was 83. That was 83. That's 90. If that's 90, what is z?
90 degrees.
And there's your three answers. Number 8. What do I know about triangles?
That they all equal to 180.
Okay, so give me an equation that I can write that allows me to solve for x.
2x plus x 10
Plus x plus 10.
plus x 10.
It's not x10, it's x plus 10.
X plus 10 equals 180.
Okay, now solve that. It's the next algebra step in solving that equation.
Combine like terms.
Good. How many x's do you have in total?
So there's 2, and so
2 plus 1 plus another one.
4x.
Okay. I'm going to add that 10 to that 10, so I'm going to have 20.
20
Now what's the
equals,
next step?
so it'd be 4x plus 20 equals 180.
Okay, now what's the next step? We got to solve for x.
Subtract 20 from both sides.
Okay, now you have that. Now what's the next step?
So then you subtract 180 from 20.
No, hold on. Well, 180 minus 20 is 160. I've done that.
Oh, my bad. Sorry.
Okay.
Then you subtract
You don't
one.
subtract.
You divide.
Okay. Divide both sides by 4.
Yes.
So
And
x is equal to 40. And now let's go up and answer the rest of them. What's angle A equal to if x is equal to 40?
okay. So isn't okay.
We solved for x. That angle is 2x.
Oh, so it'd be 2 times 40, right?
Mm-hmm.
So that will be 80.
Okay. And angle B is x plus 10. What's angle B?
Oop,
X is 40.
50.
Okay. So we have that angle is 50, that angle is 80, and that angle is 50. Do those add to 180? It's always good to check, just to make sure you haven't made a mistake.
Yeah.
And they do add to 180. 50 and 50 is 100, plus 80 is 180. Okay. Let's look at number 9. Okay. Geometry problems like this, if you don't know where to begin, just start filling in angles that you know how to calculate.
Yeah, that makes sense.
Okay? In other words, they are looking for this angle right here, ABC. But before we can figure out what ABC is, we have to figure out what the other two angles are. So what's this angle right here?
28.
Okay. What's this angle right there?
28.
No.
Oh, wait.
It's a linear, it's supplementary. Remember your magic number in geometry is 180. Whenever you have a linear pair, in other words, BC is a straight line, one of those angles is 128, what's the other one? They are supplementary.
152.
They have to add to 180.
Yeah.
Well, 152 and 128 don't add to 180. They add to 280. It's just 52. It's not 152.
Oh,
Maybe I misheard you.
52.
Okay, you see why it's 52? Those two angles have to add to 180. Oh,
Oh, okay, that's the thing I messed up.
pair.
Okay.
It's a linear pair. Whenever you have a straight line and you have a line intersecting, angle 1 and angle 2 always add to 180, no matter what their angles are.
All right.
Okay, and that's what we're looking at there. BC is the straight line, AC is this line, and we got two angles, and they're linear angles. You always want to recognize linear angles and vertical angles. You got the 28 from the fact that those two angles were vertical angles.
Yes.
Okay, so now you know two angles of this triangle. Whenever you know two angles of a triangle, you can always figure out the third one.
Yeah.
So what is it?
So Would C be 128?
No, we're not looking for C. You're right. C would be 128, but that's not what they're looking for. They're looking for angle ABC. In other words, they want this one right here. Hold on, let me start again. This one's 28. This one's 52. We'll call this one X.
Yes.
Okay. What do you know about these three angles?
That they all have to add up to 180.
Okay, so write out the equation that says those three angles have to equal 180. Tell me what it is.
So would be 28 plus 52 plus X equals 180.
Okay, now solve that for X.
Okay.
Do you have a calculator in front of you?
Yeah, I'm doing that right now.
Okay.
Is it 100?
Uh-huh. It is. Okay. And you can test that yourself by adding those three angles and see if they add to 180, and they do. Let's look at number 10.
10.
They want DEF. They want this angle right here. And they also want angle D, which is X plus 50.
Yes.
Okay. What do we know about that angle? The first one they want, DEF. What's its relationship to 5x? You know what? There's an easier way to do this. Let's do it the easiest way.
Okay.
You're looking at a right triangle, correct? That means it's a right triangle.
Yes.
The two angles that are not the 90-degree angles have to add up to what?
90 degrees.
So I got X plus 50 plus, we'll call that Y, just to throw in a different variable. That has to equal 90. So it means X plus Y has to equal 40. Doesn't help. I got to go back and do it the hard way. I was afraid I would. Can you define angle 1 in terms of X? Based on this, you got a linear pair again. Okay?
All right.
That's 5x. What does this have to be? Supplementary, right?
Yeah.
So that means 180 minus 5x. That's how you do that. In other words, when you don't know what that angle is, it's in a variable. The one thing I am absolutely certain of is that this angle is 180 minus 5x. That's what supplementary means.
Oh.
Right?
Yes.
In other words, if I had an angle and this was 2x, then this would be 180 minus 2x. Whenever you know that an angle is supplementary, up here, the supplementary is I made it 180 minus 129, right? So that's always what you do when you have a linear pair, is it's 180 minus that. Okay, so now I know all three angles. Give me an equation.
So, x plus 50 plus 180 minus 5x.
And I'm going to put that in parentheses.
All right.
Because that's the angle right there. In other words, that's one angle. That's another angle. What's the third angle?
90 degrees.
So plus 90. All that has to equal 180, right?
Yes.
Okay, now I can move the 90 over by subtracting 90. So now it all has to equal 90. You with me?
Yeah.
Okay. Now let's remove the parentheses before we gather like terms. I want you to remove both sets of parentheses. What does it leave me?
X plus 50 plus 180 minus 5x equals 90.
Perfect. Now solve that.
Alrighty. So it'd be
You don't have to do it all in one step. You can do it in a couple steps if you want.
okay.
Gather all your x terms together. How many x's do you have?
So we have 1x right there by the 50.
Forget that for a moment. Just focus on that and that. You're combining those two.
Yeah, that would be 6.
No. 1 minus 5.
Oh, 4.
Minus 4x. Takes care of that. Takes care of that. Combine those two.
$230.
That all has to be 90. Now what?
Subtract both sides. So subtract
from both sides.
230.
Okay. So that leaves minus 4x on the left side. What's it leave on the right? 90 minus 230 is what you're doing.
Negative 140.
Okay. Now, what's x equal to? What's the last step in solving for x?
Divide negative 4.
Okay. What do you get?
$35.
Okay. So that's what x is, but notice they didn't want x. That's not what they're asking for. They're asking for angle DEF.
Yes.
Well, that is 180 minus 5x. So what is, you know what? It's actually a little bit of an easier way to do it. They also want angle D. What's angle D of x equals 35?
$85.
Okay. And it's also very worthwhile to know that the two acute angles are complementary. So this other angle they're looking for is not just 180 minus 5x. I know that it is complementary to 85. Well, what angle is complementary to 85?
90.
Complementary means they have to add to 90. Supplementary means they have to add to 180.
Yeah.
So what number adds to 180 adds to 85 to give you 90?
5.
5. Notice how my two acute angles in this right triangle add to 90. Always, no matter what your right triangle is. If I have a right triangle, angle 1 and angle 2 add to 90 degrees. 100% of the time. Okay. So we didn't have to use that complicated 180 minus 5x to figure out that that was 5. Notice that I could have 5 times 35 is 175. So you have 180 minus 175. You get 5 degrees that way also. But that's much harder to do than the complement of 85 degrees. You're going to find that two of the most valuable skills in geometry, the most valuable one is subtracting from 180. You can see why.
Yeah.
There are a dozen types of problems where you have to subtract the 180. To find out that angle there, you have to subtract 180 minus 128. Okay, to find out that angle, you have to take 180 minus 28. So you are always subtracting from 180. That's just something you have to do repeatedly.
Yeah.
And occasionally 90. Not as often. 90 isn't nearly as important because you're usually dealing with triangles and the sum of the angles is 180. Or you're dealing with linear pairs and the sum of those angles is 180.
Yes.
Okay. So 180 is the magic number in geometry. Okay, so here we're going to use the Pythagorean Theorem.
Mm-hmm.
Okay. What's the Pythagorean Theorem say?
A squared plus b squared equals c squared.
A squared plus b squared equals c squared. C is what?
The hypotenuse.
Okay. So in this problem, c is x.
Yes.
One of the sides is 5, right?
Mm-hmm.
What's the other side?
5.
Also, because of that hash mark. In other words, that's actually an isosceles triangle. Two sides are the same. So it's 5 squared plus 5 squared equals x squared. That's 50 equals x squared. Now, how do you solve that? Trying to solve for x, not x squared. How do you solve an equation where the main variable you're looking for is being squared? Remember, you're always doing the opposite. So you want to take the square root.
Yeah.
I want to take the square root of both sides. Okay, well, the square root of x squared is what?
X.
That's the key. That's what we're trying to solve for. So x is equal to the square root of 50. Now, let me ask you, does your teacher want your answers in radical format or decimals?
I have no idea. It doesn't say. She didn't tell us.
It's radicals. Okay? I'll tell you. If she didn't say, then it's radical.
Okay.
Because if you put that into a calculator, you're going to have to approximate the answer. It's going to be 7.1 something and goes on forever, and then you're going to have to round it off. Okay?
I got 7.07106778.
That's not the answer she wants.
Yeah, I know.
It's not an accurate answer. Square root of 50 is the actual accurate answer. There's only one problem with the square root of 50. It can be simplified. Okay, let's talk about simplifying radicals. The square root of 50, what we're looking to do is find factors of 50 with one of those being a perfect square number. Okay, well, your perfect square numbers are 4, 9, 16, 25. You see what these are?
Yeah.
2 squared, 3 squared, 4 squared, 5 squared, 6 squared, and so forth. So, can you find a factor of 50 that is one of those numbers? By that I mean, do any of those numbers divide evenly into 50?
No.
How about 25? You have 2 quarters in your pocket. How much money do you have?
Oh, 50.
Okay. So it's equal to the square root of 25 times the square root of 2. And you can always do that. In other words, you can always separate it into 2 radical signs as long as the 2 numbers multiply to 50. And they do. Now, the reason I do that is because square root of 25 is 5. So that whole thing, the square root of 50, that's the proper answer. 5 square root of 2.
Yeah, that's what I got.
Okay. But notice that's not a decimal. That is not 7.00 stuff.
Yeah.
In other words, your calculator gave you 5 square root of 2?
Yeah.
You're kidding. What kind of calculator do you have?
The Casio.
Really? And it'll convert those to simplified radicals.
No, they do not.
Okay. So you got 7.0 with a bunch of decimals.
Yeah.
The only way to get 5 root 2 is this way right here.
Yeah.
Okay. You're not going to get it from any calculator that I've seen.
Yeah.
Okay, so number 12, give me an equation. We're using the Pythagorean theorem on all 3 of these. So how does it apply here?
All right. So it would be 8
A
8.
squared plus B squared equals C squared.
Yes. So it'd be 8 squared plus B squared
Hold on.
equal
What's B?
Y.
Okay, so it's 8 squared plus Y squared equals what?
17 squared.
Okay, now let's take it step by step. 8 squared is 64. Tell me in your calculator what 17 squared is.
Okay.
269? No. 349. What is it?
280.
289?
Yes.
Okay. Now what?
And then you would subtract.
Algebra is almost more important than geometry.
Yeah.
Every one of these geometry problems comes down to an algebra problem.
Yeah.
So your algebra skills need to be pretty good.
Yeah, definitely.
Okay, so what next?
So subtract 64 on both sides.
Okay, that's going to give me 225. So now I have y squared equals 225. How can I solve for y?
So, and then you square root 25.
Or square root both sides.
Yes.
Remember in algebra, you can do anything you want to one side as long as I do it to the other.
Yes.
Okay? And I mean anything. You can paint a yellow stripe on the left side as long as you paint a yellow stripe on the right. And that is a bit of an exaggeration, but not as much as you think. In other words, it applies to pretty much all mathematical operations. Integrals, derivatives, logarithms. As long as you do it to one side, you can do it to the other. The advantage of taking the square root of both sides is what's the left side become? What's the square root of y squared?
Y.
Okay. What's the square root of 225?
15.
15, exactly. So that's what y is 15. Now notice that that is an 8, 15, 17 right triangle. And I mention that for one reason only. There are, on a test, the favored triangles they're going to give you, that it helps if you have them memorized, because then you don't have to do the math. Is a 3, 4, what's the hypotenuse on that?
X?
5.
Oh, 5.
In other words, that is called the smallest perfect Pythagorean triangle. Is a 3, 4, 5 triangle. In other words, there's no such thing as a 2, 3, 4 right triangle or a 1, 2, 3. So if you're looking for the smallest right triangle where all numbers are whole numbers, this is it, 3, 4, 5. Now it can be 30, 40, 50. It can be multiples. It can be 6, 8, 10. But those are triangles you're going to run into repeatedly over the next few years. So it's good to memorize them, because if they told you one side was 3 and the other side was 4, you wouldn't have to do any math. You'd know instantly that the hypotenuse was 5. Okay, there's the next smallest one is 5, 12, 13. So if you see a 5 and a 13, you know this side's 12. In other words, the advantage of memorizing these are you don't have to do the math when you're confronted with one of those triangles. And the third smallest one is the one we just had on that problem, 8, 15, 17. So these three, particularly the first two, are worth remembering because it saves you a whole lot of time and math if you know this. In other words, if I say, here's a right triangle, and this side's 8, and that side's 17, and there's the right angle, I don't have to do math to figure out what x is. What is x?
For which one?
This triangle up here.
It would be 15.
Yeah. In other words, you didn't have to use the Pythagorean theorem. You did, but you didn't have to go through it. So it was much faster. Okay. So memorizing at least this one, the 3, 4, 5, and the 5, 12, 13. You'll run into both of those hundreds of times. Not exaggerating. Hundreds of times.
Wow.
So 13. Give me an equation, or is that a 3, 4, 5 triangle? Sometimes they try to fool you, and this is one of those times.
Oh, well, that's
the 3, 4, 5, the 5 has to be the hypotenuse. So that 12 is not a multiple of 5. So even though 8 is a multiple of 4, doesn't help. Okay, so I've got to use the Pythagorean theorem here. So give me an equation to write.
8 squared plus 12 squared.
Make sure you do the two short sides.
Oh. Oh, my bad. Oh.
Always.
C squared.
Z squared equals what?
12 squared.
Okay. Now in your calculator, let's see. You don't need to do it in your calculator. I can do this one in my head. Z squared equals 144. Now what?
And then subtract 61.
64, okay. So
Yeah,
I got
64.
Z squared equals 80. So what's Z equal to? Z squared equals 80. How do you figure out Z?
80. You square root the 80.
Okay. So Z
And
equals the square root of 80. Now the question becomes, is that simplified? In other words, if you put square root of 80 down there, you're going to lose a point at least. Because that's
oh,
not simplified. Think of factors of 80. Let's talk about factors of 80. Here's the way I figure out factors of 80. I start with 80 and 1.
yes.
Try to divide 80 in half. I can do it, so I got to double that, make that 2. Can I divide 40 in half? Yes, I can. Double that 2, make it 4. I can still divide 20 in half. Double 4 makes it 8. I can still divide 10 in half. Double 8 makes it 16. Now I think I'm done. I think I have all of the factors.
Yeah.
Which of those factors has a perfect square number in it? Remember over here on the far left, here's my perfect square numbers. These are good to memorize. Always know your perfect square numbers because it's the only way to simplify these radicals.
Yeah.
Which of these numbers is a perfect square number?
16.
And you want the biggest one if you can. 4 is also a perfect square number.
Yes.
So I could do it with 4, but I'd have to do it in a couple of steps. Whereas if I do it with 16, I got 16 times root 5, right?
Mm-hmm.
Square root of 16 is 4, so that becomes root 5. So this is the answer for Z, 4 root 5. Now before we go on, I'm going to back up a second. Is all you really need is to find a factor that is a perfect square number. Well, let's say I didn't see the fact that 16 was one of the factors. Well, you know 4 is, right?
Yes.
So I could do it this way. Square root of 4 times square root of 20, which is 2 root 20. Problem is, root 20 can be written 2 times the square root of 4 times the square root of 5, right?
Yes.
In other words, that is equal to those two. Well, square root of 4 is another 2. So now I have 2 times root 5, which gives me that 4 root 5. So I get the same answer. It's just that I had to do 2 extra steps because I didn't start with the largest perfect square number.
Yes.
16, a lot of people don't realize that 16 is a factor of 80. Your average student's not going to see that. They are going to see that 4 is a factor of 80. Everybody knows 4 divides into 8 perfectly. So everybody's going to see the 4, but very few people are going to see the 16. So when you're looking for factors of that number, try to find the biggest perfect square factor. It'll shorten the time of the problem.
All right.
All right, let me scroll down here a little bit. Got about 10 minutes. Should allow us to do most of these. What do we know about this angle and this angle?
That they have the same angle.
Nope. That line is not bisecting that right angle. Splitting it into 2 pieces. What do you know about those 2 pieces?
That they equal to 90 degrees.
Yeah, that's 90 degrees right there. So the equation is what?
3x plus 17 plus x plus 25 equals 290 degrees.
Yeah. Now notice I didn't use any parentheses at all. The reason is that I have nothing but plus signs. When you have to use parentheses is when you're subtracting. If I was subtracting x plus 25, I would have needed to put a parentheses around it, and it would have mattered. As long as you're adding, you don't need the parentheses. All right, now gather your like terms. What do you got?
4x plus 17
plus 42. Go ahead and combine that one and that one. Now what?
And then subtract 42 and 90 minus 42 would be 48.
Okay.
And then divide 4 on both sides.
Okay.
X will be 12.
Okay. Now, look at the problem. They're not asking for x. They're asking for CAR. They want to know this angle CAR, which is 3x plus 17.
Yes. So, it would be 53.
Okay, good. And that's pretty much the way we're going to do every problem we're looking at here. If we run out of time before we finish, is we're going to take their pictures, we're going to take our knowledge, and we're going to write an equation.
Okay.
We don't need these multiple choices. They're pretty much worthless on problems like this. You have to solve it.
Yeah.
The multiple choice, I didn't even look at the multiple choices, you notice. Okay. Now, if you come up with an answer that's not one of your multiple choices, then they matter because that tells you you've made a mistake. And you can go back and redo the problem, redo your math. So the multiple choice is helpful in that sense. You still have to come up with the angle, but if it's not on your multiple choice, it's a giant red flag telling you you made a mistake. Go back and start from scratch.
Yeah.
Okay. What equation can I write here?
6x plus 40.
Okay, hold on one second. Let's back up. You were doing it right.
Oh.
I didn't interrupt you because you were doing it wrong. I interrupted you because I saw what they were looking for. They're looking for this angle. What is that angle?
Oh, 180.
Exactly. We don't need to do any math here at all.
Oh, okay.
Okay. Notice that what they should have, it's kind of a trick question because normally they would be looking for this angle or that angle. Okay. So the fact that they're looking for the angle of the straight line is, like I said, a trick question. That we don't need any of those formulas. We always know the angle of a straight line is 180.
Yes.
So I know that before I even start. So you can save a lot of time because that would have taken another minute to write the equation down.
Yeah.
And the equation would have been 6x plus 40 plus 4x minus 10 equals 180. And you'd have solved it, and you would have gotten some value for x, which I don't even know, and I don't care because they didn't ask for one of those short angles. They asked for GIT. That's always 180 degrees. Okay, number 16. They want TOY. It tells you the value of looking at what they're looking for. Because if I didn't look at that first, I would have gone ahead and done exactly what you were doing. I would have gone through all the arithmetic and the math and the algebra. But halfway through that, I looked at the question. I realized we don't need to do any of that. So always look at what they're looking for. So in
All
this
right.
case, they're looking for this angle right there.
Yeah.
So what do we know about that diagram?
That it's
When you have two lines that cross, it creates something called vertical angles. And what
yeah
I just drew, what is 1 equal to?
to 2,
And what's 3 equal to?
4.
So in this diagram, tell me what I can say.
That 3x plus 63 is equal to 15x plus 21.
Actually, it's 15x minus 21.
Oh, sorry, my bad. I didn't
That's
see
what
that.
it says, okay? Now, solve that equation. When you're presented with an equation like that, where you have x's on both sides of the equation, really the first thing you should decide is which side are you going to get your x's on? Are you going to put them on the left side or the right side?
The left side.
No, that'll give you a negative coefficient. Negative signs screw everybody up.
Lower.
Put it on one side that leaves a positive coefficient, that's the side you should put it on. There's
Okay.
nothing magical about having x on the left side.
Ah, good
Be on
to
the
know.
left or the right side, doesn't matter. So since a positive coefficient would be created if I move the 3x over to there, leaving 12x, and that means I got to move the number and combine it with the 63, so what goes on the left side of that equation?
$84.
Okay, now divide that by 12.
$7.
Okay, we're still not quite done. So all we've done is solved for x. X is 7. So we know that that angle right there, the one they're asking about, is supplementary to that, right?
Yes.
So if x is 7, what is the angle that I just circled?
84.
Okay, so now let me erase that. This angle is 84 degrees. What's this angle? They're a linear pair. In other words, linear pairs are always supplementary, which means you have to subtract 84 from 180. Like I said, you are always subtracting a number from 180. You should get good at it because it's a very valuable skill.
96.
Good. I said good because most people want to say a 10, start with a 10. But you know that number and that number have to add to 17, not 18. Because we have another 10 with the 4 and the 6. So 96 is the answer. And I apologize, I've taken you a few minutes over the time. So I'll let you go, but we got quite a bit done here. I hope it's helpful to you.
Thank you.
When's your final? Is it tomorrow?
Yeah, it's tomorrow.
Good luck.
Thank you.
Luck on your final. Have a good Christmas and New Year's, and maybe we'll talk to you next semester.
All right. Same with you.
All right, Ricky. Bye-bye.
Bye-bye.